Hi, so welcome to our project. We did the national bank problem where we were given five different stocks, A, B, C, D, and E, where they were hidden to us, and we had to analyze them through market data and trade data through CSV files with hundreds of thousands of lines of code. So as you can see here, I used React to make the project and made the app very interactive and easy to use. So users can come here, select different periods to look at, and for example here, we can look at the trade data for all five of the unknown stocks. Now users can also compare to market data and look at the differences here. So once market data loads in, because of the amount of file size, it takes a bit of time. We can compare right here. Down below, we have our analysis for all 31 periods and overall conclusion of our findings.
The statistical approach with a momentum-based pairs trading algorithm, which basically longs or shorts the slower stock based on the trend of the faster stock. This was done um, for 5 minute intervals, so using the correlation of 5 minutes and trading on the next 5 minutes, ensuring there's no look-ahead bias. And this was done 12 times for the entire 60-minute hour interval that we have. This was done 15 times for the entire training data, and here we can display the results for every period. So here we can see the rebalancing intervals for the returns over time, and we can also see the correlation over time.
I'm now going to go over the file structure for the project, which includes the algorithm files, the testing data, and the results. So firstly, we have three files for the algorithm and the backtesting, which are trading algo, main algo, and data visual. We also have data cleaning, which does the processing of the data into 5-second intervals, which are stored in process data here for the different periods. Then we have the results, which are outputted from the main algo file. They go into result folders, which go all the way to 20, 1 to 15 for the training, and 16 to 20 for the testing. And as you can see, we have the result metrics, we have the trades, we have the return over time, and finally we have the correlation of the stocks over time.
Okay, so for this part, we decided to do an RNN model to predict the movement of stock prices. So the first thing we did was clean the data. There was a lot of data that had mismatching timestamps, so we had to take care of that. We also did some data visualizations to get a better understanding of the data. So our RNN model is based off a LSTM-based model with two hidden layers, each size 50 with a dropout 0.2, and of course a linear model or a linear layer for the forward, for the output layer. For the data preprocessing, we had to do a lot of data preprocessing to make sure that it was primed for training, and we ended up getting a really good test accuracy for the model or for the training data. We ended up getting around 0.9, 0.8 test accuracy, and for the training data or test data, sorry, we also got really well. We got around 0.8, 0.9%